Hey everybody, welcome back to episode 64 of the video series in which we program an entire video game from scratch in the C programming language. Today I'm using a noise filter on my microphone. I've been using OBS to record YouTube videos for over a year now, and I just now figured out that microphone can have a noise suppression filter put on it. So we're going to see how that works, how that makes the audio. If the audio quality is still good, hopefully it'll filter out the background noise, the air conditioning. It's the summertime. It's very hot across, I guess, the entire northern hemisphere right about now. So there's always an AC unit running in the background. My wife and my cat walking around the house doing things. Hopefully all that noise, all that background noise will be filtered out. So what we are going to do today is first we're going to look at our comments from since the last time. So a comment came in. This is actually on episode 13, which is a long time ago, and I think it is right around probably the time period when we started delving into SIMD to speed up our pixel rendering. The commenter says, "Hey Ryan, actually the issue with memcopy versus SIMD code that was suddenly faster was because we were using memcopy S before, and it looks like memcopy S is a lot slower than memcopy." So I'm pretty certain that we've talked about this before, but I'll talk about it again. Yes, of course, even without doing any benchmarking, it stands to reason that memcopy will be faster than memcopy S because memcopy S does additional stuff that memcopy doesn't do, which is verifying, validating the size of the buffer before it begins copying. And nothing comes for free, so it would stand to reason that memcopy S is going to be slower. It's also supposedly, allegedly, the more secure version. All of Microsoft's _S versions of like the C runtime functions are supposed to be more secure, have more bounds checking and stuff like this. In practice though, they still can be misused and abused, and it's not it was far from a panacea introducing those _S functions. Let's go ahead and let's start up Visual Studio here. Just get a feel for what this guy's talking about. I have memcopy S. Let's search for memcopy S. Okay, so we are still using this memcopy S function, and it's in the blitzstring to buffer function, which is one of the slowest functions in the game, in the critical path, the hot path of our code. So the question is, would we be better off making this memcopy S a memcopy? So there are definitely different schools of thought about this. A lot of people will say, if you use memcopy, if you use like unchecked memcopy instead of memcopy S, then you're automatically fired because it's not safe. And they may or may not be able. They probably won't be able to tell you why exactly. But they'll say, it's drilled into a lot of people's heads that this is the only acceptable thing. This is the only acceptable version of memcopy, is the one that has the _S on it. But I am curious to see though if we can get a bit of a speed up if we converted this to memcopy. Let's go ahead and I'm trying to decide if I just want to run this or if I want to run this with like the profiler. I kind of want to run, let's do the performance profiler and click on CPU usage, and let's start it and see what happens. All right, so I'm just going to sit here at the title screen for a second and let Basically the only thing really happening right now is this blitzstring function, because I'm blitting all this debug text stuff and all of the menu item stuff. So there's a lot of text being slatted onto the screen right now. You'll also notice that it does have an effect, because whenever I remove the debug text in the upper left hand corner, when I re-enable it here in a second by hitting F1 on the keyboard, I want you to notice that the FPS, the frames per second, it was significantly higher. And then as soon as I started drawing that debug text on the screen, that debug text, ironically, drags the FPS down significantly. So get ready, watch this. So we were approaching like 4,000, upper 3,000s, and then as soon as I hit F1 to draw the debug text, it drags the FPS down to like 18, 1900, 2000. So the reason why I called that ironic is because debug text is not really supposed to have a dramatic effect on the runtime of the program, but here it does. So all right, so the profiler is running in the background. Let's go ahead and stop that. We'll let that collate. Okay, so our top functions. Memcopy S is one of the top functions. You'll see that query performance counter is also one of the top functions. However, remember, don't get distracted by this. Query performance counter is actually, it's not dragging our performance down. Remember that we are purposely calling query performance counter in a tight loop. So we're purposely spinning and using query performance counter to burn CPU, and that's how we throttle our frame rate to get a nice cooked 60 FPS. So ignore that for now. However, memcopy S is like the only thing showing up in that list right there. If we scroll down to hot path, we'll see. So we get down here into WinMain. Obviously, like I said, ignore QPC for now. Click on render frame graphics. We'll drill down into that for a little bit. Let's see. Drill into that. Okay, so within render frame graphics, the highest hitting function in render frame graphics was draw debug info. So if we drill into draw debug info, you'll see, of course, the hardest hitting function, or the hottest function in there, is blitzstring to buffer. And then within that, it's memcopy S. So now that we have some numbers, we have some profiling numbers. Let's go ahead and close that. And let's see if we can increase this with by moving this from memcopy S to memcopy. And again, I know a lot of people are going to say, a lot of people have the attitude that you're not allowed to use the old school memcopy. And in fact, I think it was the deprecation warning that was actually preventing us from using the old school memcopy in the first place. Let's see. So this is destination, and then the source, which is that guy right there. Size, of course. I forgot to add the size. Okay, it didn't give us a hard time about using memcopy, which I thought it would actually. I thought we would have to go and like define some constant to turn off deprecation warnings, but apparently not. So since we're on a roll, let's continue with this one. Memcopy destination. source and size. What am I doing here? There we go. Okay. Now let's profile it again and see if we see any difference. So upon first inspection, I'm already noticing a significant difference here. And I think last time with the debug text enabled, we were hovering at around 1800 to 1900 FPS. So, and now we're getting around 3000. So, very substantial improvement there. I'll just let this run for a couple more seconds. And all right, I'll go ahead and exit that. That should be long enough to get us a decent sampling. Now we'll see that memcopy S is no longer on this list of top 5 hottest functions. And it is now replaced by inverse MDCT, which I don't even know what that is, and is probably something we have no control over. So let's go back to the hot path CRT startup and main, WinMain, render frame graphics, draw debug info, blit string to buffer, and now we'll see that, okay, so I believe if you can remember from the last session, a memcopy S, whenever this was memcopy S here, the proportion was something like 2.5% or maybe 2.5% or so, or something like that of the total composition of blit32 BPB bitmap to buffer, or I mean of blit string to buffer, right? So by going to memcopy, you can see that the CPU usage has gone down drastically by several times, by like one. It's like 1/5. So yeah, it is definitely significant. So let's see. Close that. Close that. Don't save. There we go. So there you have it. I mean, there is a very significant difference in performance, but also you also have to consider, depending on who you're working with and who's reading your code. Just keep in mind that there is a whole school of thought that I'm reminded of that old Benjamin Franklin quotation. He says something to the effect of, "Those who would sacrifice liberty for security deserve neither." That's what I'm reminded of when I say there are some people who would say those who would sacrifice security for performance deserve neither. Kind of the same concept there. So, like I said, I mean, you got to use your own judgment. Is memcopy_s really that much safer? Yeah, maybe in certain situations, but in other situations, not really. Like I said, memcopy_s, it's still, you can still hack it, you can still exploit it, you can still create bugs, both accidental and malicious. So memcopy_s is not a silver bullet. So I don't know. I guess that's all I can say. I will. Memcopy S is safer, but is much slower. Memcopy is faster than memcopy S, but you lose the security features, the security benefit. I just realized the noise filter is probably masking out much of my keystrokes too, which is probably a good thing. The keystrokes, I have a very loud keyboard, so my keystrokes are probably somewhat annoying. Okay, so we're done with that, and I think we're done with comments in general at this point. I mean, the memcopy s thing was pretty much the only interesting comment this time. All right, so I'll close that. Okay, so the first thing I want to do before we really continue is I want you to know that I did a little bit of work off camera just in the interest of keeping things moving along. I don't, obviously don't want to do too much off camera, but also want to keep the momentum going and keep making progress without getting bogged down by sort of the lot of this like really mundane uh, stuff. But anyway, there are a couple things I want to talk about, and this is the list of things that I did while I wasn't on the recording, and so I just want to talk you through those things. So this first one here is the assert macro that we did last time, and I'm going to go ahead and go to it over here in main.h, and this one this one actually came to me through a comment on Reddit. So I'm going to talk about it here. Last time I talked about how we had to break this assert macro apart into two different if-def paths because we started using Clang in the last episode, and Clang was complaining about this mess that I had here, which is like um, there. This bit right here, which Clang was complaining about, and it was telling me that it was giving me warnings, not errors, but compiler warnings, telling me that this was not a valid thing for some reason or another. And because of that, I decided to say, you know what, well, that statement is kind of nonsense. So what I'm instead going to do is I'm going to replace that with this built-in trap, what Clang calls a built-in, and what Visual Studio would call an intrinsic function or intrinsic. However, since they're intrinsic, these functions like this are intrinsic to the compiler. They are compiler dependent. So only Clang understands the built-in trap thingy, and only Visual Studio understands this UD2 intrinsic. But under the hood, they both result in a UD2 CPU instruction, which is specifically designed to be an undefined, or I say quote unquote invalid instruction that is guaranteed to get you to a debugger. It's guaranteed to crash the process. So Clang was complaining about this right here, and instead of just removing it, what I could have done is I could have also put the volatile keyword in there, and that would have actually, it would have produced the same effect. It would have crashed, but it also would have removed the warning that Clang was giving me. And this is a good time to talk about why exactly Clang was warning me about this. And it was because without that volatile keyword in there, it was giving me the clue that Clang might not always execute that statement. It might get optimized out. And if that statement got optimized out, then my assert wouldn't work. So it was saying, hey, if you use volatile instead, you are basically guaranteeing that this is never going to get optimized out. So the volatile keyword, I don't know if we've ever talked about the volatile keyword before, but It's probably one of the I don't know if it's one of the most difficult concepts to really wrap your head around in C, but it's overloaded because different people use it. They define it differently in their own minds, and it's also used in different programming languages. Like C sharp also has volatile, and other programming languages also have volatile, and it doesn't necessarily mean the same thing in all those different programming languages. But I guess the easiest way to describe it to you right now is the volatile keyword is if you have multiple threads that are all if you have multiple threads that are accessing this data, which is this piece of data right here, at the same time, using this volatile keyword is a way of making the compiler insert um, basically to prevent the compiler from optimizing any accesses to this variable. And what I mean by optimizing is like the compiler, when it's optimizing your code, um, it can reorder instructions and uh, do things that lead to better performance, but they might cause unpredictable results if you have multiple threads accessing this variable at the same time. Not only multiple threads, but most importantly, like when would you ever want to use the volatile keyword? In my opinion, the number one time when I would use the volatile keyword is when I am dealing with like a piece of hardware, a hardware device. Basically, it's letting the compiler know that there is an external factor that's external to our program. In this example, let's say it's a piece of hardware, like say it's a some sort of peripheral that you have plugged into the serial port on your machine, and it updates this piece of memory, and you don't know when that might happen, and you have no control over when that might happen. So this keyword gives the compiler that hint that hey, this variable could change in memory at any time, and you don't know when that might happen. So you need to make sure and be extra careful around when you're accessing this data in memory, and you need to disable any sort of optimizations that might cause you to basically come up with unpredictable behavior results. So hopefully that's clear. Anyway, that's why Clang was warning me about this. It was saying, hey, this might potentially get optimized away, and if that statement got optimized away, then that would break your whole assert macro. It wouldn't do what you thought it did. But in the end, I decided to, you know what, that was kind of a nonsense piece of code anyway. It's better to use this notation right here with this built-in trap, which results in a UD2 CPU instruction because uh, number one, it UD2, the UD2 CPU instruction is guaranteed to not get optimized away. It's guaranteed to always result in a invalid operation exception, and secondly, it makes it clear what you're trying to do. So like when someone else comes back and reads this code, they'll see, oh, this he's intentionally trying to crash the process here. So whereas with that other weird thing, they'll be like, well, maybe he's just an idiot. Maybe he does. I don't know. Like yeah, that's definitely going to crash. But is that really what he meant to do? Because that code is nonsense. So anyway, this is much better. Okay, next. Let's see what's next. I'll go ahead and erase that. Okay, so draw window. DrawWindow. I rewrote it and made it way awesomer. I'm going to go ahead and go to it right here. Draw window. Yeah, so like I said, I rewrote this draw window function from scratch because I got the feeling last episode that this function was just, it was getting out of hand, it was sloppy, and didn't even work the way I really wanted it to. So I rewrote it completely. The comments, obviously, those are the same. If the window flag horizontally centered flag is specified, X coordinate is ignored and may be 0. If vertically centered is specified, the Y coordinate is ignored and may be 0. Background color is ignored and may be null if window flag opaque is not set. Border color is ignored and may be null if window flag bordered is not set. Either the bordered or the opaque flag needs to be set, or both, or else the window would just be transparent and invisible. So yeah, there's my documentation. The window border will cut into the inside of the window area. Good to know. And then I left a to-do piece, implement a rounded corners flag. So here you go. Basically, the code has been altered. First of all, I removed that assert that had us, it basically imposed the restriction that the size of the window had to be a multiple of 4. And that's nonsense. I mean, obviously we should be able to draw a window that is of any dimensions that we want. It can be 11 by 11 or 27 by 13 or 64 by 64. We should be able to, we shouldn't have that restriction. So obviously not important, remove that. And all I did here was starting screen pixels calculated the same way. But then I go about implementing each one of these flags. This is the opaque flag. And then, obviously if you specified the opaque flag, then your background color needs to be present. And then I'm using memcopy here. So I took out all of the STOS-D stuff. I took out all of the inline assembly, and I just moved it back to memcopy because basically, as I was recording the previous episode and as I was playing with like STOS-D and inline assembly, I came to the realization that, hey, I'm doing way too much here. It may be that when we get to the end of the road and the game is almost done and we get into the optimization phase, then maybe I'll start bringing some of that stuff back. But when you're first setting off writing this stuff, there's no reason to immediately jump into that level of optimization where you're talking about inline assembly. It just isn't necessary. This memcopy right here will work just fine for our purposes, and the compiler, even in release mode, the compiler is probably going to optimize it into instructions that are just as efficient as any inline assembly that I was going to come up with. That isn't always the case, but it's just sort of like a trade-off. It's like, how much effort do you want to expend optimizing these memcopy calls when the compiler is probably going to do a reasonable job of optimization? So that's why I decided to just, drop all the STOS-D stuff, drop all of the inline assembly stuff, and just go back to basics here. We're basically just drawing the window. We're drawing an opaque window, an opaque rectangle, basically, using the background color. So then we go, and after we've done that, we then go and draw the border around the window. The other advantage that this has over the last version of the DrawWindow function is that this version allows us to draw a transparent window that has just a border. So if you just want to draw just a border around something without affecting, without filling in the inside of it, you can do that, which we couldn't in the last version. The last version just drew an opaque window and it obscured whatever else was behind it. So exact same situation though, where you've got like it goes around the edges and draws a border using the border color that you specify. So now you can have a window that has a different background color and a different border color, and this is going to come in handy whenever we are fighting monsters and the monster has almost killed you. Your HP is low because your character is almost dead. I want to make sure that we're able to paint all this stuff red. I want to paint the window border red to signify that you're seeing red because you're very low health. You're about to die. So yes, and then we keep drawing the border. Okay, we're done with the border. And then we implement a shadow effect, which the shadow effect is just a black, one row of black pixels that is shifted over one to the right and one pixel down all the way along the bottom, and then up the right-hand side of the window. And then here you can see that I have if-def'd out all of my old code, which you can still see. This was the inline assembly that I was doing. Here's this window width must be a multiple of 4, just garbage. Like, I don't know why nobody called me out on that. It was completely unnecessary. I'm just drawing 1 pixel at a time, right? So let's see, we don't need any of this stuff. And in fact, now that I've showed you that stuff, I can go ahead and delete it. Actually, instead of deleting it, because I do kind of want to keep, I'm sort of somewhat proud of my inline assembly. I may want to keep it around just for posterity. So I'm going to cut, and I'm going to go to code scrap. Code scrap. This is like the code graveyard. I'm going to save it in there. There we go. Now it is saved for posterity. So without further ado, I've done a lot of talking about the DrawWindow function. Let's go and see what it looks like now. In order to test our new and improved DrawWindow function, you will see that I have drastically improved the character naming screen, which you can see right here. So first of all, I changed the background color to a gray color, and that was simply because I needed 3 different colors to test my window border color and my window shadow color. So I think I can use Zoom It to zoom in here. Yes, I can. There we go. And there we go. Yeah, so you can see that the window border is white. You can see that the shadow is offset. It's sort of down and to the right, and you can see that it's sort of offset down there. And then you can see that it extends, the shadow extends up the right hand side and then stops 1 pixel short up here in the corner. And then of course I did the same thing by putting a window around all these letters here, and I did not specify the opaque flag so that the window is just transparent, so you could still see the letters through it. So yeah, that's how the window works. There's only, I think, there are a couple things I still want to do with this DrawWindow function. I would eventually, sorry, let me get out of here. I want to implement a rounded corners flag, which I will show you. I'll minimize this, minimize that. If you take a look at my desktop wallpaper here, you may or may not recognize this depending on how old you are. This is a screenshot of Castlevania 2 Simon's Quest from the original Nintendo Entertainment System. And a dialog box pops up here whenever the sun sets and whenever it becomes nighttime. This little dialog box pops up on the screen. It says, "What a horrible night to have a curse." And it just strikes me as funny because, I mean, that's just like a weird thing to say, right? It's like the phrasing is weird, and I think it probably is because of like the Japanese to English translation. It just is a really funny thing to say. But anyway, before I get off on that tangent, I want you to look at this dialog box and take a really close look right there. you'll see that they have these rounded corners. It's just the final finishing touch on the window. It basically is just I'm taking one pixel out of taking a one pixel bite, and I mean that BITE bite, not BYTE. Taking a little nibble out of each corner of the frame is how we make that rounded corner. Like I said, it's just a finishing touches, sort of a nice little finishing touch. I would probably say that this in my game, this probably needs to be implemented a little more with a little bit more finesse, because we'll use this as an example, and I'll zoom in again. Over here in this corner, like this would have to be. I want the rounded corners effect to work both with and without a shadow, right? So, and maybe with and without a border too. So it all depends. The way that the rounded corners are going to work exactly depends on what other flags were specified. So, for example, this bottom left corner, I'm going to take this pixel, this white pixel, away where the border used to be, and it's going to be the background color. So it would be like a gray color. But over here on the right-hand side, if we look at the bottom right-hand corner, I can take this white pixel away down here in the bottom right-hand corner, but it wouldn't be gray. It would actually become the shadow color, because the shadow is underneath it, right? And then I would have to take one little nibble away from the shadow as well. Does that all make sense? So that is sort of the capstone project of this draw window function. And I'll say let's leave this. Maybe someone would like to do this for me and submit a PR in which you have implemented the rounded corners flag using the description that I just gave. So that is the draw window function, and it works fine. Obviously, we now know the difference between memcopy and memcopy S. So there's no reason to belabor that. Yeah, that's it. All right, let's go back up to the top. And let's go back to the top. There we go. I can remove that because we've talked about draw window. Window border color, that was part of that. We've already talked about that. Increased the fade gradient, which is just simply all I did. This is very straightforward. I simply took this used to only have this array right here, G fade brightness gradient. That is an array, and it used to only contain 40 elements that represented 40 frames. So a fade in, fade out scene transition would only take 40 frames, and I just felt that was a little too short, so I just increased it to 50 frames, and I put one extra shade of gray in there to just sort of make the fade in and fade out during scene transitions a little bit, just a tiny bit longer and smoother. Just changed it from 40 frames to 50 frames. Now keep in mind, when you do this, you have to make sure and also modify this other pound define up here. This guy right here, fade duration frames, was 40, is now 50. That's fine. Very simple. And we can now remove that from the things to talk about. Okay, so the next thing I fixed while I was not recording was I improved the title screen and options menus so that they wrap around instead of stopping at the ends. So let me demonstrate that real quick. And So before, the behavior before was that when you press down, the down key, you get to exit and then it just stops. Like if I continued to press the down key, it wouldn't go any further. But now, if I'm on exit and I press down again, it now wraps around to the top. Just like that. So if I keep pressing down, it wraps around. If I keep pressing up, it wraps around the other way. I simply think that's better. I did the exact same thing to the options screen, which is all very simple. Did the same thing. If you go to the character naming screen, I have changed the behavior of this guy, this little selection menu right here where you select all the letters. I changed it quite significantly to where it wraps around. The first two columns of characters include the back button, and back and OK now wrap around to each other. And then these guys in the middle, the last two columns of characters now wrap around, including the OK button. But these middle characters now wrap around just amongst themselves, if that makes sense, right? Just like that. And I feel like that's probably more natural. The way it was working before was kind of non-intuitive, so I think it works a little better now. And the way I did that was character naming screen .c PPI. There we go. You'll notice that I didn't have to make a ton of these pound defines. I didn't have to like do a pound define for every letter of the alphabet. I wanted to avoid that because that would be kind of messy. But I did do a pound define for the row width, which is 13. And then I'd made, since the back button and the OK button were sort of special case, I did make pound defines for those. And then I made a macro for selected text, which is just a string compare, which basically is saying, like, I didn't want to have to type out the string compare thing a bunch of times because it's long and it's kind of hard to read. So I basically wrapped that up into a macro, and now it's very clear what the intent is here. It's like if I'm on the back button, then I want you to back up a row. If I'm on the OK button, then I want you to move 2 characters back or 2 elements back, which actually ends up landing us on the lowercase z. So then I just have some if-else statements here that just implement all the logic. And then what I do here is I do a switch on the first character of whatever menu item you're on. And since all of these little guys, all these letters, they're all menu items, right? So they're all single characters. But remember that technically the name of a menu is a string. It's a char star. It's not just a char. So remember, this has to be treated, you have to keep in mind that even though it's just a single character, it's still a string. So notice I'm specifically looking at the first element of this array, of this string, and then I'm casting it to a char, which of course has an integral value, which means I can use it in a switch case. See, like capital A is 65, capital B is 66, etc., etc. So for all these letters, I'm implementing the behavior that I want them to have. And that is how I improved the character naming screen. So if you don't like the way that it works, let me know. And I think it works pretty well. All right. That was that, right? Yeah. Done talking about that. All right, so next item on the menu, improved Clang build script. So obviously, if you watched the last episode, you'll know that we introduced the Clang compiler, and we made this game ready to be built using Clang. So let me open this build script, this Clang _ x64 debug build batch file. I'll open that with Notepad. No, I don't want to download your update package. Okay, here it is, and you'll notice that I have this almost is ready to replace Visual Studio as a text editor. And the reason why I say that is because um, I have this window up here is the function list, which works pretty nicely. So you can jump to all the different functions in a C file. And then over here on the right hand side, I have this folder as workspace window, which just lists all the different files in this folder. So um, I'm basically just trying to replicate what you see in Visual Studio, where you can navigate through your entire uh, collection of header files and C files over here on the right hand side. And then also when you're within a C file, you have this drop down menu here, which allows you to jump around to different functions. So I would say the only downside here is that I can't control the font size of these two windows over here, as far as I know. So, and that's not for me, that's actually just for you guys. I know when I'm broadcasting or recording these videos, uh, the font size needs to be bigger than it otherwise would normally be, just so you guys can see it on YouTube or whatever. But anyway, this is pretty good, and I think the autocomplete the autocomplete actually probably works a little bit better here than it does in Visual Studio. Certainly works a lot faster. Um, so yeah, I mean, I do like this, and I might want to move over to this full time. I haven't decided yet. There's still some things that some old habits that I have from Visual Studio that are hard to break. There are also some things in Visual Studio that are still useful, like that performance profiler that we used earlier. Um, so I don't know if I'm ready to move over to Notepad++ full time yet, but we're getting close. Secondly, I don't know if I've never used like Visual Studio Code, for example, but I know everyone talks about VS Code and how awesome it is. So it's probably high time to give it a try. But anyway, what we were actually talking about was the Clang batch script, the build script. You'll notice that I improved this significantly from last time. So what the build script does now is basically, it just turns, echo off and then turns it on when it needs to be on. And what it does down here is if the project was successfully compiled, then it automatically goes, hey, do you want to launch the executable under a debugger? And if the user says, yes, I do, then I start WinDBGX with using, our executable as the debugger. And as I talked about in the last episode, WinDBGX is just one debugger. There are at least several different debuggers that are pretty good in Windows. Use whichever debugger you like, but I think WinDBGX is pretty good. And there's an old version of WinDBG, but don't ever use that. And the reason why is because it's not updated anymore. Okay, so the team that maintains the WinDBG debugger for the last several years, they have only been working on WinDBGX, no longer maintaining the old version of WinDBG. So I don't care if you like the old version better. Eventually, you're going to have to move forward with the new version. And if you don't remember from the last episode, you can download that from the store, which I think is kind of dumb, but search for WinDBG, which is this right here. It's in the Windows Store. You can download it. Of course, it's free. There it is, WinDBG. They call it preview, but like I said, it's the only version that is being worked on and has been worked on in the last several years. So anyway, there's your debugger. So there's the script. So let's go ahead and run the script. source repos AB and run the script. And this is using the Clang compiler to build this project. And then once it's done, you'll see that it asks you launch executable under the debugger. If you select no, then it just returns you to the command prompt. But if you select yes, I'll show you what's going to happen. Yes. Okay, so you'll see that a new process has just magically appeared, and this is WinDBGX. I may just start calling it WinDBG from now on. This ribbon up here, if you don't like it, you can get rid of it by pressing this little arrow up here. Okay, so what has happened is this is a debugger. It is attached to our new process, which is gameb_clang.exe. And the question is, well, what do I do now? The first thing you want to do is you want to set a breakpoint on your main function. Probably what you want to do. So let me make sure all this font size is big enough for you to see it. Okay, so type BP for breakpoint. We're setting a new breakpoint. gameb_clang is the name of our module, and then you type bang, and then the name of the function, which is winmain. Okay, don't worry about that warning. We've set our breakpoint. If you type BL, it stands for list breakpoints. You can see that we have set one breakpoint. It says E for enabled. It means this breakpoint is enabled. That's the address of the breakpoint. You'll see that we have source code information. This is line 236 of main.c. The only way you get this is if you type is with the -G and the -G code view command line parameters. Remember, those are needed in order to bake all of the debugging information into your executable and also to produce the PDB symbol file. And then, yeah, here's our breakpoint, and you can see game B, winmain. That's our breakpoint. So if I type G, G stands for go, and this means the execution of the program will continue until our breakpoint is hit. And there it is. You'll see that happened in no time at all. And you'll see that it automatically popped up source code, which again, that's because that only happens if you have the full debugging information compiled into your executable, and you have the PDB file, the symbol file. If you had a release build of the executable, you wouldn't get all this. You wouldn't get like all this source code and stuff. But here we go. We're in winmain, and our game is running in the background. You can start stepping through from this point on. So if I type P, that means step over. So you can see I'm stepping through, and every few steps it's probably going to stop to load a symbol, load another symbol for like Windows. If I type .sympath, you can see that my sympath is simply https msdl.microsoft.com/download/symbols. So just public Microsoft symbols that I'm downloading off the internet. And then, yeah, so here's stepping over all this stuff. Stepping over. I have okay, so here's an interesting experiment. I'm going to actually go ahead and close this. I guess I'm going to hit stop debugging. And that is going to, yeah, that kills our process. I'm going to close that. I'm going to go back to here, go back into main, go back into here, log message. actually, my function list, where is log message? There it is. Now I'm going to actually comment that out. This is based on some debugging that I had to do off camera, but I'm going to replicate it now so you can see what sort of behavior you might expect. So with that commented out, I'm going to go ahead and recompile it, because that line that I commented out, that message box, it wasn't there before in the log message function. Let me back up a second. Launch WinDBG preview on its own. Click on Launch Executable. Find our game in x64, release, debug, there we go. Open. Okay, our executable is now open in the debugger. I hit G for go. And we'll notice something interesting has happened here. Something unexpected. And the debugger has automatically stopped our program because something has gone wrong. And you'll notice that I'm on a UD2 instruction. Now we know, based on what I talked about just earlier in this episode, what a UD2 CPU instruction is and where that possibly could have come from. We know that the only way that this could have happened is if one of our assert macro statements was triggered, right? So if we look over here in the source code, I'm in the log message function. And this is a good example of how sometimes, this is one example of why debugging can often be hard, because of some, either we don't have all of the right information, or because most commonly the compiler has optimized our instructions so that the CPU instructions don't always line up with the source code line by line, because CPU optimization makes debugging very difficult. That's why, you have, if you're going to debug your app, you need to debug it in debug mode and not release mode. So this right here, where it shows that we're on this line, this string copy S line, that line, that's kind of meaningless. That's not exactly where we are. So we need to figure out where exactly we are. If I type the letter K in the command window over here, this shows us our call stack of where we are currently. And you can see that we started in WinMain right there, and then we went to load registry parameters, and somewhere in load registry parameters we decided to call a log message A, and then somewhere within log message A we hit one of the assert statements, and we failed the assert and we crashed the game. We just need to figure out which one it was. Like, I have faith that we did crash somewhere in the log message function, but I don't have faith in this little arrow right here. This is not exactly where we crashed. So what we could do is, let's back up a little ways before that. Let's go, let's say, right here to the very beginning of this function. So if I click right there to set a breakpoint, and then actually what we may do, I think I could just hit restart, right? Hit this restart button. There we go. It restarted the execution of the program, landed us right here on our breakpoint. And now from here, let's begin stepping. Oh, are we actually there? Where are we? We run K. Oh, we're not there yet. Hang on. Let me just type G for go until we actually hit that breakpoint. There we go. Now we actually hit the breakpoint. Now from here, I'm going to step, press P to step over. Okay, now we're on a call to reg get value A, which was apparently successful. Okay, now we are on log message A. Now I'm going to type G to step into log message A because we know that we crashed somewhere in here, right? So I'm going to keep going, step over, step over. So this wasn't where we crashed. That wasn't our problem. Just keep going. Switch log level. That, okay, we're still going. We're still going. We're still going. We're still going. Now we get to this file, log file handle equals create file A. Step over. Now you'll see that it jumps to this line right here, which we know is bogus, but we know that something funky just happened. Let's type X to examine our local variables. Let's see. Nothing there. I don't like that. I think a lot of our variables have already been optimized out, which I don't really like. Let's keep stepping. And there's our UD2 instruction. So here's the thing. We did learn some interesting, we learned that this is where we fail right here. We learned that we failed on this little section of code, this little snippet right here. Our create file call failed. So we couldn't open the log file. That was our problem. And what happens is when you run this, the game would just silently exit. And that's why I put the message box in there, because then at least we would know, that it failed. Let me go back here to the debugger. If I do a bang GLE to type get last error, this at least gets us the last error value in our tab, right? Each thread has its own last error value, and it's access denied. All right, so what I'm doing here is basically, since I'm using public symbols, I obviously, I don't have source code level access to these functions, because create file A and RTL init, ANSI string EX, these are Microsoft functions. So we only have public symbols. So what I was doing instead was, when you whenever you call a function on 64-bit Windows, you're going to store the first four parameters inside of registers C, D, 8, and 9, right? So RCX, RDX, R8, and R9. So I knew that if I manually checked the contents of these registers, that I would at least find the log file name that we're passing into create file, which is in RDX. So if I inspect the RDX register, I'll see that I have game.b.log here, which is what we expect, but there's a nuance here that I really wanted to show you. We know that our access to gameb.log resulted in an access denied. The question is why? So let me just stop, exit the debugger for right now. What if instead we do process monitor, which process monitor procmon.exe, this is another tool this is another sysinternals tool that allows us to basically observe the behavior of the entire machine at a very low level. Process monitor basically inserts a filter driver that observes system behavior. It can't do everything, but it can look at the result of every Windows API call that's made all the way across the system. So what we're going to do here is I'm going to launch Process Monitor. I'm going to look for path is gameb.log, and I'm going to use that as my filter, and then I'm going to hit OK. Okay, so now Process Monitor is running, and I'm going to call WinDBG, and I'm going to launch executable, launch gameb Clang. I'm going to hit go, and it crashes. And now I'm going to go back here. Instead of path is gameb.log, I should do path contains gameb.log. Add. Okay. There we go. Now you can see that my, here we go. Process name, gameb.clang.exe. You can see that the operation was a create file. You can see that the path was Windows System 32 gameb.log, and obviously the result of that operation was access denied. It was access denied because this path is wrong. That path is wrong. It shouldn't be in System 32. And I didn't launch the game as administrator, so I don't have access to System 32. I don't have write access to System 32. Which brings us to the moral of this story, is that whenever you are using WinDBG and you launch an executable, you need to make sure and set your working directory correctly, okay? So you need to make sure that your, not arguments, but your start directory is correct. Right there. So whenever I launch the game through explorer.exe right here, like this, and if I just double clicked on gameb.clang.exe, my working directory would automatically be set to this directory, which is why it works. But when I use WinDBG, it does not automatically set the start directory properly. So you have to specify the start directory and then hit OK, and then say restart, go, and now this time it's not crashing. The game runs successfully under the debugger. And then when you hit stop, you have to go back to the debugger, because terminate process, you have to, there you go. Okay, so that's WinDBG overview. So now we talked about that. We talked about, what else do we have to talk about? Main.c, that's our new and improved Clang build script. Okay, fixed Dpi Awareness, which is a manifest file problem with Clang. So there's one thing that I noticed, and in the interest of time, since I know we're already over time, I won't do a full demonstration of this, but I noticed an issue. Our Clang build of the game, when I run it under Visual Studio, and I go to the options screen, you'll notice that I have an array of screen sizes here to choose from, and they wrap around like so. I can do very small screen size, I can do very large screen size, and then like so. Thing is, I noticed is in the Clang build, for some reason it was not letting me get to the largest screen size of 2304 by 1440. It was only letting me get to 1920 by 1200. It wasn't letting me go any larger than this. And I thought, that's very strange. Why would the Clang version be any different than the Visual Studio version? And it turns out, after some debugging, which with WinDBG, which we just talked about, so now you can do that too. I noticed in the create main game window function, there's this situation right here. As you'll recall from many episodes ago, we have this DPI awareness issue where my monitor is physically it's a 1440p monitor, so it's 2560 pixels across by 1440 pixels vertically. However, because I'm recording these videos and I want my text size to appear larger, for the sake of recording, I increased my monitor DPI, or increased my monitor size, which I think is like somewhere in here, somewhere in the setting. Let's see, let's just type DPI in here. Here we go. There we go. This right here, I changed this scale from 100 to 125. That makes all of the text and the taskbar and everything else a little bit bigger. And I just did that for you guys just so that you could see my screen a little bit better. But that had the unintended consequence of making Windows API there are a lot of Windows API calls that now give incorrect measurements, and a lot of Windows API calls now think that my monitor is not 2560 by 1440 anymore. They think it's smaller than that because I have this 125% scaling. So Windows says, well, to counteract that, what you should do is you should mark your application as high DPI aware by setting that in the manifest, which is in Visual Studio, is down here. You go to your properties, you go to manifest, and it's in here somewhere. There it is, DPI awareness, per monitor, high DPI aware. Your manifest is an XML file that gets embedded into your executable when you compile. In Clang, I don't know how to do that. In Clang, I don't know how to embed a manifest the same way that Visual Studio does. So what I do in Clang instead is I set the DPI awareness via a Windows API call. MSDN says that they prefer you to set this via manifest rather than setting it via code. And the reason why is because if you set the high DPI awareness via manifest, it allows Microsoft to basically change it if they have to change the behavior of it in later updates to Windows, in newer versions of Windows. They can change the behavior in a way that is seamless without you having to go back and change your executable. Like if they made some sort of change to where they were like, okay, well now instead of calling set process DPI awareness context, well now if you want it to work properly, you have to call set process DPI awareness context EX or something like this. And now every application maker would have to go back and change all their code, and we all have to update all of our apps, which would suck. So that's why they recommend that you set it via manifest. But like I said, I don't know how to do that in Clang, so if you do know how to do that in Clang, please let me know. But that's that issue taken care of. Okay, next, switched to the built-in AVX2 pound define instead of using our custom AVX pound define, as well as removed SSE2 code for now. So back here, where before somewhere in my main.h file, I had I had like this special pound define where I was like defining pound define AVX. I'm taking that out because both Clang and Visual Studio both already have a built-in underscore underscore AVX2 underscore underscore pound define. I think Clang does. Let's go back to the build script. Yeah, see, I didn't have to set this AVX. I didn't have to set this AVX thing in my Clang build script. It's already set. I believe whenever you do this option right here, it already sets that pound define. So it's already set in both Visual Studio and Clang. So I just moved over to using that instead of using our own custom AVX pound define. Other than that, it pretty much works the same. There was some broken SSE2 code that wasn't working very well, so I just removed it for now. I may revisit that later if we decide that it's useful. So AVX2 gives us support for processor like AVX2, that advanced AVX2 instruction set started appearing in processors at around 2013 to 2015. So if your processor is 7 years old or newer, you should have no problem with AVX2 instructions. And if you do have an older processor, then you can just use the non-SIMD version, and we'll just let our compiler optimize it. We'll probably do a decent job of it. So remove that. Let's see. Improved character naming menu behavior, we already talked about. And then this is the last big one that I'll talk about. And then we'll be out of time. We're already like at 1 hour and 20 minutes or so. But this is the last big one. So there was a bug. There was a bug that was really bothering me where during scene transitions, and I'll go ahead and start the game up here. During scene transitions, like for instance, when you hit this portal, I'll skip the monster battle. When you hit this portal, it transports you to the dungeon, and then you would automatically like jump out of the portal, even though you had taken your hands off of the keyboard completely. And in fact, I'll go ahead and show this one to you since it's a pretty significant bug fix. So in main.c, I'll go to process player input. There we go. There we go. Here we go. And then there we go. Before, I just had this, right? So in process player input, if G input enabled was false, which input is disabled whenever you're transitioning from one scene to another. So like when you go through a door, player input is temporarily disabled while we do this fade out and fade in sort of animation. Input is also disabled whenever your window is out of focus. So like if you alt tab over to something else, we want to make sure that we've disabled input. So it's just like this. And I think this is all I need to do. Just run this, and hopefully you'll be able to see this because you can't see my keyboard. But you'll just have to trust that when I have this game playing, when I go through that portal, when I go through this portal, and as soon as I hit the portal, I'm going to take my finger off of the arrow key. But even though my hand is not on the keyboard whatsoever, my character, whenever input is re-enabled again, is going to automatically jump out of the portal. And I'll go ahead and show you what that looks like. There, did you see that? It was kind of subtle. But I'll go back the other way and do the same thing. I want you to notice that as soon as I get through the portal, and as soon as input is re-enabled, my character just sort of automatically walks out of the portal, even though I'm not touching the keyboard at all. There. Hopefully you saw that. That was really bothering me. It's almost as if like some movement gets queued up somewhere whenever between the time that input is disabled and whenever it's enabled again. All that I needed to do to fix this was to take this away. So now, even when input is disabled, I'm still at least going to check for, I'm at least going to gather input state about whether the keys are pressed or not, even when input is disabled. And gamepad as well. Add your gamepad input to it as well. Now when I get down to here, I'm going to say now that we've gathered all of the input state, if your input is disabled, I want you to jump down to input disabled, which is all the way down here, which again, I want to make sure and gather, I want to save the state of all of my game input. So what we're doing, all we're short circuiting here is when input is disabled, we're going to still collect all of the key state, all of the input state. We're just not going to act on it. So we're skipping all of this, all of the PPI underscore functions. So that's all you had to do, and now it no longer, there's no longer any problem like that. And this not only works during those portal scenes, but it also works during these menu transitions as well. We had the exact same problem before with the menus, where if you tried to move your cursor when input was disabled, you wouldn't, your cursor wouldn't move. But then as soon as input was re-enabled, your cursor would like jump to the next item, even if your finger was not on the key at that moment. So that was a very annoying bug, and I'm glad to have fixed it. So let's see, that does it, I think. Fixed. Yeah, there we go. And so that is that's all we have for today. We're already at about an hour and a half. So next time, I promise I won't do any more work while I'm not recording. So the next episode will be, we're going to do monsters next episode, I promise. Yeah, anyway, that's all I had for today. If you liked what you saw on today's video and you want to continue seeing me produce this content, then please hit the like button, hit the subscribe button, sign up for notifications, tell your friends about this channel, all this good stuff. You can also follow me on Twitter. You can also download the companion GitHub repository that goes along with the source code, and you can follow along at home. You can, submit pull requests if you think you've got some really awesome feature that you feel like I need, and all this kind of stuff. And that's all I had for today. So thank you very much for watching, and I will see you next time. Bye.